Hi there. For this week, the basic idea is to study what limits are. A limit is trying to find the value of y when you are given some specific x value, or more precisely, when you're infinitesimally close to a specific x value. For normal continuous functions, we would just substitute that value of x on the screen, for example, in blue, to find the limit as x gets infinitesimally close to 0. For this function, it's nice and continuous. We can just substitute x equals 0, and we get a value of 2. The green example is a more complicated function that has some discontinuity in it, and therefore, when we try to substitute x equals 1, it doesn't really yield anything which is computable. We get 0 divided by 0, which has no answer in its current form. So what we do in those situations is use a graph or a table. Sometimes we can use algebra to simplify things and try to discover what that y value would be infinitesimally close to, in this case, x equals 1. So what I did here is I used Desmos, and I created a table with the function that we couldn't find the value directly. You can see that Desmos doesn't have the value of 1. It's undefined. But if I use a whole bunch of points that are extremely close to 1, like 0.9 or 0.999 or 1.0001, you can see all the values of y are either extremely close to 0, either negative 0 or positive 0, which is the same as 0. So we would say that the limit, or the y value, gets infinitesimally close to 0. So that's the basic idea. The second application that we kind of want to deal with in this section is applications to slope. Slope is just change in y over change in x, y2 minus y1 over x2 minus x1, and we're going to be using our limit idea to try to find slopes of curving things. The classic example is a distance time graph, where we have some sort of function and we're looking for the slope of the line at a desired location. And that line is called a tangent line, and the tangent line slope would just be, again, the change in the y over change in x, which in this case is change in distance over change in time. How distance changes over time is commonly referred to as velocity, or sometimes as speed. So you'll see different applications dealing with velocity in these homework problems. The purpose of these sections is basically to give us the building blocks towards calculus, towards the derivative. That's the big idea in Calculus 1. So these are the building blocks. The stumbling blocks that oftentimes students have are finding those limits of the complicated functions. And remember, I find that the easiest way is just to make a table, plug in a sequence of x values that are getting very close to our desired location. Okay, well, good luck. And again, let me know if you have any questions or need help with anything.